AOPS number theory 5.25. If n has 2 prime divisors and 9 total divisors, how many divisors does n squared have? So if n is equal to p to the power of a times q to the power of b, where p and q are prime because it has 2 prime divisors, then since it has the number of divisors would be Tn, which is a plus 1 times b plus 1, and since it said it had 9 total divisors, that means a plus 1 times b plus 1 is equal to 9. Now since 9 is equal to 1 times 9 and 3 times 3, that means, well, yeah, so since a is greater or equal to 1, and b is also greater or equal to 1 because it can't be 0, because then p to the power of 0 or q to the power of 0, it would just be equal to 1 or basically nothing. So that means a plus 1 is equal to b plus 1, which is equal to 3, because it can't be 1 times 9 then. So a is equal to b, which is equal to 2. So the number of divisors n squared had, so n squared would be equal to p squared times q squared in brackets squared, which is equal to p to the power of 4 times q to the power of 4. So the number of divisors n squared has would be 4 plus 1 times 4 plus 1, which is 25. AOPS number theory 5.26. Find the smallest positive integer that can be written as a product of two factors each greater than 1 in exactly 3 different ways. For example, 70 is one such integer, since 70 is equal to 2 times 35, which is equal to 5 times 14, which is equal to 7 times 10. Note that the order of the factors does not matter. So since in this example it excluded 1 times n, because there's no 1 times 70, that means it's actually 4 ways, like 4 different pairs. So that means there are 8 positive integer divisors. So Tn is equal to 8. So the prime factorization of n could be p to the power of 7, or p to the power of 3 times q to the power of 1, or p times q times r. So p to the power of 7 smallest is 128, which is too big. Now p to the power of 3 times q to the power of 1 is can be 2 to the power of 3 times 3, which is 24, and p to the power of 1 times q to the power of 1 times r to the power of 1, the smallest is 30, so the smallest is 24, so 24. AOPS number theory 5.27. How many of the positive divisors of 14,400 themselves have exactly 8 positive divisors? So this number is equal to 2 to the power of 6 times 3 squared times 5 squared. So 8 is equal to 7 times 7 plus 1, or 3 plus 1 times 1 plus 1, or 1 plus 1 times 1 plus 1 times 1 plus 1. So that means it must be in one of these forms, p to the power of 7, or p to the power of 3 times q to the power of 1, or p to the power of 1 times q to the power of 1 times r. So if it's p to the power of 7, the largest is 2 to the power of 6. So it's not p to the power of 7. P to the power of 3 times q to the power of 1. So 2 to the power of 6 is the only one with the third exponent in here. So it has to be 2 to the power of 3 times 3, which is 24, or 2 to the power of 3 times 5, which is 40. If it's p times 1, p times cube times r, though there is one of each, so it has to be in this combination, 2 times 3 times 5, which is 30. So there's 1, 2, 3 different positive divisors. AOPS number theory 5.28. How many positive divisors do 8,475 160 having common, so the GCD, if you do the GCD, if you simplify it and stuff, it'll be, the GCD is 840, so 840 is equal to 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1. So the number of divisors of 840 would be 3 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1, which is 4 times 2 times 2 times 2, which is 32.